Here is I have a capacitor circuit. You filming?
Mm-hmm.
Great. A capacitor circuit where I've got two capacitors. So I think that maybe those of you in the back stand up so you can kind of see it a little bit. A capacitor circuit where I've got two capacitors in parallel. So that means if you can see here, it's branching off into the two different nodes of the circuit and coming around this way. So what do you think is going to happen when I connect the battery? Light bulb's going to go on. Do you think it's going to go on? So we see the light bulb's going on. And what do you think is going to happen to the amount of time that the light bulb's going to be on? It's going to be longer. So both of these capacitors have the same capacitance, which we'll get to today. It's a function of the capacitor itself. And essentially what this is behaving like is like we have a capacitor with double the area. So think back to that example that we did at the end of chapter 18, where we talked about the two light bulbs in parallel, and they behaved like double the area, the same as happening here. And then of course, if you were to, well, we'll get to the next one. Okay, so here I have a circuit where I have a battery that connects to a capacitor, which connects to a light bulb. And then on this side, when I hook it up, I'm going to have it connected to another capacitor and then to a light bulb. So the light bulb is entirely isolated from the battery. Remember, current doesn't flow over a capacitor. Do you think this light bulb is going to turn on? Some of you are nodding. Some of you look unsure. Why do you think it might turn on? Those of you who are nodding. So while you're thinking, let's go ahead and we can just discharge this capacitor, and you'll see that in this case that discharge will last longer as a result of having those. Okay, so moving back to this one, we can see that indeed the light bulb does turn on. And basically what's happening here, this isn't that much different than the capacitor circuit that we've seen before, because it's still pushing those charges to rearrange themselves within this wire here. You're still, well, now it's going out, but you're still having current through here until these capacitors are charged. Does that make sense? Any questions? All right, so, and the last demo, I can go ahead and we'll discharge the capacitor so you can see the bulb will go back on, and there we go. So in this this circuit here, I have actually the most common application of a capacitor. So for this one, we can see the battery is connected. I'll go ahead and connect it now. So we've got the battery that's connected, and we can see the capacitor is actually isolated from the battery. So this light bulb's just going to stay on because this circuit's just following along like this. Does anybody see what the benefit of a circuit like this might have? This is the most common application of a capacitor in real life. So everybody watch this light bulb. I'm going to disconnect one side of the battery. It stays on. Now it's pulling current as it's discharging the capacitor. What might that give you time to do? Change the battery. So that's the biggest application of capacitor circuits, is that you'll have one right here that will be charged up from the battery so that if something goes out, you will continue to have power flowing while the capacitor is discharging. All right, thank you.